Hi there, this is Math 8, Unit 5, Lesson 1, and we're looking today at inputs and outputs today, okay? So first of all, we're going to be talking about how to make some rules, and they gave a little setup here of dividing by 0, and I want you to study the statements carefully. Here we have 12 divided by 3 equals 4, and the reason they say that that works is because 12 equals 4 times 3. And that is a true statement. When you multiply 4 and 3 together, you do indeed get 12. So then if you were to divide it by 3, you get 4. You used to call these probably fact families in elementary school and things that kind of work together, right? And so they move down to this next statement, and it says, well, based upon that then 6 divided by 0 equals x, because 6 equals x times 0. So trying to use that same logic here to have this make sense. Well, let's go back here. If 4 times 3 actually works, which it does, it gave us the value of 12. Over here, is there a value of x that you can multiply by 0 to end up with a 6? And the answer to that would be no, there's nothing. Any number times 0 is simply going to be 0, which is why you actually cannot even divide a number by 0. It's not possible. So, is there a value to place in x to create a true statement? We would say no, there's not. It's not going to work because there's no number times 0 that will give you a different number besides 0. Alright, from this point here in your class, you probably went on to an activity called Guess My Rule. And your teacher may have given you some cards to look at and to take a card and to see what happens and play it with you have a little rule, something that changes here. I have here on the online version of our book here, a little app, looks like this. Okay, and we're going to look at Guess My Rule in this way, kind of in the digital form. So here's the idea, is I put the number 1, that's my input, and that number goes into the blue, into the little black box, okay, where there's a rule happening here inside this box. And when it comes out, that 1 becomes 0.5. And you can see here in the chart, it started off as a 1 and becomes a 0.5. And so the question is, what is the rule that is turning this 1 into 0.5? What's happening to go from here to there? So if you think about it, in a case like this, what we're probably saying is we're saying, well, 1 to go to 0.5 is just cutting it in half. We might say that would be divided by 2. So our rule might be something like divided by 2. I'm going to press the go button and see what happens with the next number. Right? If I put 1 in there again, I still end up with 0.5. Seems pretty good. Let's change my input real quick. Let's try something like the number 2. So if I change the number to 2, if this is dividing by 2, what will we expect to have? Well, 2 divided by 2 is usually 1. Let's see what happens. Let's press go. 2 goes in, and out comes what? Out comes 1. Okay? And so for our rule, we could probably guess and say something like divide by 2. Okay? Do I want to create sliders? I don't know what that means. Let's say sure. Invalid function. It says nope. Right? So probably it should say divide equals 2 is probably what it should be there. But that's okay. Let's try it again. Let's do divide. I've never tried this part here, folks. Equals 2. That's okay. Well, that's basically what's happening though. So we divide by 2. Let's see, divide by 2. We make that our rule, and that's what tends to be happening there. Let's try it again. Let's try a 4. If we were to make this a 4, and if it was dividing by 2, my iPad's going to work today. It's not going to be nice to me. Come on. Why is it going away? Alright, well right now it's not being kind. Let's try a new rule. Alright, I'm ready. New rule. Alright, let's get rid of this slider. And go. The 2 goes in the box, and out comes a 9. Wow, that's just crazy talk right there. I think our slider's getting us messed up a little bit. Let's try a new rule. 2 goes in, out comes a 6. Alright, that I can work with a little bit better. Okay, so 2 goes in, and out comes a 6. So what's happening to the 2 to turn it into a 6? We might say something like maybe multiplying by 3, because 2 times 3 gets you to 6. So the idea here is that there's a number you have in your input, it goes into the black box here, and there's a rule that's applied to it, and it comes out as something different. And that's the same thing you were doing today in your activity with your neighbor or your partner today. Let's take a look at section 3. All right, for each input-output rule, fill in the table with the outputs that go with the given input. Add 2 more input-output pairs to the table. All right, so we're going to begin with a number. We're going to begin here with 3/4. And what it wants us to do with 3/4, that's our first one here that we're looking at, is we're going to add 1 to it and then multiply that by 4, and we end up with 7. Okay, this is like the example here, right? So if you were to take 3/4 as the example, it's already done, 3/4, and add 1 to it, then you end up with 1 3/4. Now, if I multiply that by 4, that might be a little tricky to do. So first I'm going to rewrite this as an improper fraction. So 4 times 1 is 4, plus 3 is 7. So I have 7/4 actually. I'm going to multiply that by 4, or 4 over 1, and that leaves me with 28 over 4. Or I could reduce here, and notice that those would be reduced to 1 and 1, or just know 28 divided by 4 is equal to 7. So starting with 34, and following the rule, which was add 1, here's my add 1, multiply by 4, I end up with 7. And we put that in the table here like so. So let's do that with the next couple values here. If I start with 2.35, and I add 1, now I'm at 3.35, right? I'm going to take that value and I'm going to multiply it by, the next step here, by 4. 4 times 3.35 is actually equal to 13.4, and I can do 40 if I want to. So there's my input, and then when I apply the rule of add 1, multiply by 4, I end up with the output of 13.40. Do the same thing with number 40 with the 42. I have my input, 42. I follow the rule. Add 1. It's my first step, right? Add 1, which equals 43. Then I multiply that by the next rule, which is multiply by 4. 43 times 4 is 172. I followed all the rules, and that's my output right there. Right? And that's the idea, from an input to an output. Just like we did in a little online video on the iPad, this is our black box. There's a rule that's being applied to whatever we're putting in there, and we have to follow all the steps in the rule to get the proper output. You could pick a couple numbers there that fill in, and I'll let you do that on your own. I'm going to move down to number 2. It says, okay, here's our example, 3/4, and our rule is here. Right? This is our rule. This is our input right there, our output there. I'm putting 3/4 in the box this time, and when I follow the rule, I come out with a 7. So the rule is this: name the digit in the tenths place. So let's break this down here. Here's 3/4 as a fraction. I want to write that as a decimal. Now as a decimal, this is 0.75. Okay? My tenths place, my rule, is whatever that digit is. And so since that's my digit, we would say that our answer is going to be 7. All right, let's take a look at the next value. We have 2.35. Our rule is name the digit in the tenths place. The tenths place is right here, so we would say the digit in the tenths place is going to be 3. And then for 42, we have 42.00. If we want to add some zeros there, we look for the digit again in the tenths place, which is here, and that's a 0, so we would say 0. And again, you could think of a couple of the numbers there to put there in those places as well. So this is another rule. Again, same input each time, but when you change the rule, it changes the output. Let's look at the next page. Again, we have the input here. Here's our input. It's 3/4. Here's our rule, which says write 7, and here's our output, which is simply 7 right there. So whatever the input is, the rule is I write the number 7, and the output becomes 7. Okay, so if I had 2.35 and I put that in the box, and the rule says to write the number 7, then what comes out the other side? Simply 7. If I have the number 42 and the rule says write 7, then what do I write? 7. So that rule doesn't have much to do except just to change the number into 7. There's not like a mathematical reason for it. It's just that's the rule, and you have to play by the rules. Okay? All right, so let's take a look at the last one here. Here we have the value x, and it says divide 1 by the input. Now the input is x, right? That's our input right there. So you end up with 1 over x. We sometimes call this the reciprocal, right? So let's take a look here. This is our input, here's our rule, and here's our output. And so they give you an example here. They say, all right, if you had 3/7 and we divide by the input, divide 1 by the input. So here's 1 divided by 3/7 because that's our input, right? Okay, when we divide that by the input, that would mean 2. In our case here, we multiply by the reciprocal. All right, so 1 times 7/3 equals 7/3, and that's what we have. Let's do that for the other numbers. Here's the number 1. 1 is our input. So we have 1 divided by our input, 1 divided by 1, right? And 1 divided by 1 is simply 1. And that's it. That's all we do with it. The next input it says is 0. Well, if I do 1 divided by 0, can I divide a number by 0? Nope. Doesn't work. So we would say there's no output because it doesn't work. And that's okay. Just for the sake of the table here, let's add another number. What if we use the number 4? If we did 4, we'd have 1 divided by the input, which is 4. Okay? So that would look like something like this. If I did multiply by the reciprocal, I could do that, or I can write it out. It would look like 1 times 1 over 4, when I flip this over, which becomes simply 1/4. Or 1 divided by 4 is really 1 divided by 4. So if I used 4 as an input, I might get an output of 1/4. What's interesting is that there are times when your output simply won't work, and that's okay just to make a note of that and say it doesn't work here. Let's take a look at your summary for today's lesson. Today's lesson was really the idea that you have an input that you put into a box that we call a rule. When you follow that rule, you come up with an output. So an input-output rule is a rule that takes an allowable input and uses it to determine an output. So we use the example of 3/4, and we use these different ones here. Okay? The key thing to remember is that not all inputs are allowable. Okay? So sometimes you can't put something in there, it's just not going to work. Okay? The rule must specify which inputs will work. So, for example here, they give you an example of, all right, this rule is great. This rule is fine. With 2, can you do 2 divided by 6? Divide 6 by 3 more than the input? Sure. So divide 6 by 3 more than the input. That means, okay, I have 6 divided by 3 more than the input. What is 2 plus 3? 5. Can I do 6 divided by 5? Sure, that works there. But if the input was -3 and I added 3 to that same rule, I'd have 0. Can I do 6 divided by 0? Nope, it doesn't work. So sometimes you have to make sure that you specify which ones are not allowed because it just won't work there. Okay, so in this case here, you'd have to say, there's the rule, that's great, but you also have to say -3 is not allowed as an input. So not all rules are going to work for every input, so you have to be careful about that. All right, let's take a look here and check out your homework. All right. Homework time. All right, so our input goes here. Here's our black box for our rule, what that's going to be, and our output goes there. And we're going to complete the table here. And this time the table goes horizontal, whereas in our lesson they went vertical, but not a big deal. So our rule is divide by 4 and then add 2. All right, so let's take a look at the first one. We put 0 in here, okay? We put 0 in here. We divide by 4. 0 divided by 4 is still 0. Remember, we can do 0 divided by 4 equals 0, but you cannot do 4 divided by 0. Okay, so keep that in mind. So 0 divided by 4 is 0. Now then we add 2 to that, and we end up with 2. Okay, so 0 divided by 4 equals 0 plus 2 equals 2. That's the first one. For the second one, we have the input 2. We divide that by 4. And so at 4, we're ending up at, right, we have 2 divided by 4 is 2/4 or 1/2. Okay, we add 2 to that, and we end up with 2.5 or 2.5, depending on what you want to work with. For the next one, we have 4 divided by 4, which equals 1. We add 2 to that for the rule, and we end up with 3. For 6, we do 6 divided by 4, which equals, in our case here, 3 over 2, right? Why is that? 6/4 reduces down to 3/2. And then we add 2 to that, and so that becomes, this right here is a 1.5, if I make it a mixed number, plus 2 really becomes 3.5. And for 8, we do 8 divided by 4, which is 2, and we add 2 to that, and so we end up with just a straight 4. And for 10, we do 10 divided by 4, which can be written as 10/4, which can be reduced down to, let's see, 4 goes in here 2 times, with 2/4 remaining, which is also 2.5. I add 2 to that, and I have 4.5 as my solution for that one right there, or 4.5. If you did decimals, you'd have 2.5, 3.5, and 4.5 there. I just chose to keep them in fraction form. Number 2, it says here's an input-output rule. Write 1 if the input is odd, write 0 if the input is even. So if it's odd, we're going to write 1. If it's even, we write 0. That's a simple rule. That's all we're doing. That's our rule here. So -3, is that odd or even? That's an odd number, so we write 1. -2 is even, so we write 0. Then we have odd, even, odd, even, odd. So there's not really a lot of mathematical computation involved here. It's just follow the rule and do what it says. Okay? All right, that's it for that one. Number 3. Okay. Number 3, we're kind of going back a little bit here. This is from Unit 4, kind of reviewing what we did in Unit 4. So let's take a look. Andre's school orders some new supplies for his chemistry lab. The online store shows a pack of 10 test tubes costs $4 less than a set of nested beakers. In order to fully equip the lab, the school orders 12 sets of beakers and 8 packs of test tubes. Write an equation that shows the cost of a pack of test tubes, T, in terms of the cost of beakers, B. All right, so what do we know so far? We know that test tubes cost $4 less, so test tubes cost $4 less than beakers. So a test tube, T, has a value that is whatever the beaker is minus 4. So test tubes cost $4 less than the beakers. That's what we know so far. The school office receives a bill for the supplies in the amount of $348. Write an equation with T and B that describes the situation. Okay, well, we know we have to have 10 test tubes and that we need to have, we need to order, 12 beakers and 8 test tubes, right? So 12 beakers and 8 test tubes. So when I order 12 test tubes, or 12 beakers, I don't know how many, plus 8 test tubes, I end up with $348. Okay, so this is going to be the B here represents the cost, or the cost of a beaker and the cost of a test tube. So I don't know what those are. Let's say it was $1, then that would mean it'd be cost me $1 each, so $8 total for test tubes. Just making that up here. So I'm using what I know, that I need 12 beakers, 8 test tubes here. All right, and so we're set there. Now the next question, mine goes over the page here, says since T is in terms of B from the first equation, this expression can be substituted into the second. Meaning, because I have the t equals b minus 4, I can take that value of t and plug it into that one right there. Okay? So it would look something like this. I'm going to write it twice, just because I'm on the same page. 12 times b plus 8 times, and we substitute b minus 4 equals 348. Okay? So we're taking this equation for t and putting it there in the place of t. All right, I'm going to turn my page because mine doesn't quite work there. I ran out of space. And it wants us to solve for b. So let me rewrite this real quick. We have 12b plus 8 times b minus 4 equals 348. We want to solve this for b. So to do that, I'm going to distribute here. So I have 12b plus 8b, 8 times b is b, 8 times negative 4 is negative 32 equals 348. I'm going to add 32 to both sides, right, to eliminate that there. Combine my like terms here, 12b plus 8b is 20b, and that's going to equal, add this up, 8 plus 2 is 10, carry the 1, 4 plus 3 plus 1 is 8, and there's 3. So I have 20b equals 380. To get the b by itself, I divide both sides by 20. And so b is equal to 380 divided by 20, which is going to be 19. So solve the equation for b. We would say b equals 19. How much did they pay for a set of beakers and for a pack of test tubes? Well, now that I know that, I can use my original equation, which was t equals b minus 4, right? Remember that one there? We plug the b into there to solve for t. So t is going to equal 19 minus 4. So t equals 15. So a beaker costs 19 and a test tube costs 15. And those become my solutions for how much a beaker and a test tube cost. All right. Looking at number 4, it says solve. Okay, so we have y equals x minus 4 and y equals 6x minus 10. So to solve this, I set them equal to each other. I do x minus 4 equals 6x minus 10. Why? Because I'm substituting this value of y into that space. Oops, sorry about that. That space right there. So I'm going to subtract x for both sides. So over here I have 6x minus x is 5x. I'm going to add 10 to both sides. 10 minus 4 is 6. Alright, so that goes away. Now I want to get the x by itself, so I divide both sides by 5. So that 6/5 equals x. And that's what I get for number 4. For number 5, it says, for what value of x do the expressions 2x plus 3 and 3x minus 6 have the same value? Well, to figure that out, I just simply set them equal to each other. 2x plus 3. When will 2x plus 3 equal 3x minus 6? Okay, so when will they have the same value is when they're equal to each other. So I subtract 2x from here, subtract 2x from there. That goes away, and 3 minus 2 is 1, so we have simply x over here. And I'm going to add 6, that goes away. 3 plus 6 is 9. And so when will they have the same value? The same value when x equals 9. All right, that's it for today. Have a great one, and we'll see you next time.